Now we're going to solve the following problem concerning the velocity of a particle. We assume that we have a particle that's moving along this line here, this straight line, and it has this velocity t arctangent of t in meters per seconds. We want to know how much the particle traveled after t seconds. Okay? So we want to find the distance that the particle traveled since it started at this time here, which we assume as 0. Okay? It has 0 velocity here at time t equals 0. And after t seconds, okay, we want to see, this is the time, we want to see how much the particle traveled. Okay? So how can we solve this problem? By the way, this is an integration problem if you want to do that. The key is to remember that the velocity is just the differentiation with respect to time of x, where x is the position that depends on time of the particle. Okay? If you want to solve this problem, you can stop here and see how you can do it. Okay, let's solve it then. So here we have x is the position that's dependent on time. To solve this question, we need to integrate. dx is giving us vt dt. And once we integrate, we get x is the integral of vt dt. Okay, let's not worry about the variables now. Okay, between what and what? The starting time is 0 and the ending time is t. And that's why we need to change this variable here. So we're gonna make x as the integral between 0 and t of v of s ds. Okay, and therefore x, the distance is the integral between 0 and t of s arctangent s ds. Okay, now this is a problem that we need to solve by using some kind of integration techniques that we know. The easiest way that I think of and that can lead me directly to the solution is we can use integration by part. Can treat this one as a function and this one as a separate function. So I can have f g, which one? F prime g is f g minus f g prime. The key here is which one is f prime and which one is g prime. Okay, if I see that f prime, if I take f prime as s, I'm gonna have s squared here, and g prime will be 1 over 1 plus s squared. This will help. This will help a lot. Okay, so I'll take f prime as s and g as the arctangent of s. And therefore I have, let's not worry about the bounds for now. I have f is s squared over 2 times arctangent of s. Let's not worry about the bounds. We'll come back to that later. Let's find the primitive now. Minus f, which is s squared over 2. I'll take 1/2 outside. S times 1 over 1 plus s squared ds. This is coming from the derivative of the arctangent of s. And therefore I have s squared over 2 arctangent of s minus 1/2. Here I have s squared minus s squared over 1 plus s squared ds. Okay, to get a primitive of this one, I need to add and subtract 1. So when I do that, I'll get s squared over 2 arctangent of s minus 1/2. I have s squared plus 1 minus 1 over 1 plus s squared ds. When I do that, I get s squared over 2 arctangent of s minus 1/2. Here, I'm going to get, let's do it one more time, 1 minus 1 over 1 plus s squared ds. Okay, and finally, I have s squared over 2 arctangent of s minus 1/2 s plus 1/2 arctangent of s. because I now did the primitive of 1 over 1 plus s squared. And therefore, I have here when I do integrate, I can now get my bounds or add c here, okay? Doing so, I can add a c and go back, or I can get the time because I wanna see the distance. So here I can go back here and get x of t is s squared over 2 arctangent of s plus 1/2 arctangent of s minus 1/2 s. Okay, this is the value that I get. So s squared. Okay, now I evaluate between 0 and t. Okay, because I still have to add the constant here or get the bounds. When I do evaluate between 0 and t, I have 0 is gonna give me 0, it's clear. I have t squared over 2 arctangent of t plus 1/2 arctangent of t minus 1/2 t. This is in meters. So this is my x. Okay, let me write it here clearly so we can have more space. xt is t squared over 2 arctangent of t plus 1/2 arctangent of t minus t over 2. Okay, so this is the position. So I want to see how much I traveled. I need to plug just the t and I get this distance. xt is in meters. So x is in meters. Okay, if I want to see how much I traveled since I started the movement, what I need to do is, if I assume that after 1 second I'll get t equals 1. Okay, t is 1, I get the 1/2 arctangent of 1 plus 1/2 arctangent of 1 minus 1/2. So I get pi over 8 plus 1/2 pi over 4 and minus 1/2. Okay, this might seem like pi over 4 minus 1/2. Okay, so this is my distance. This is in meters. Okay, the aim is to know this formula here. You need to integrate and use an integration by part to get the result. Okay, I hope this is clear, and I hope we didn't make any mistake. We don't edit the videos. Okay, if you see any errors or mistakes, please let us know. Thank you very much again.